Okay, good morning, class. As you know, this lesson will be a bit shorter, but we're just going to introduce the real number system, okay, or the number system, which is real numbers, which is on page 1 in your textbook, okay. So the number system, you've dealt with this before, okay, when you were children. You started counting, not so. Did you count in halves? 1 and a half, 2, 2 and a half, 3? No? You saying yes? Yes, sir. As a baby? No, sir. No, you didn't start counting with 1, 1 and a half, 2, 3 and a quarter. No. Not so. You started counting with number 1, then 2, 3, 4, 5, until as far as you could. Not so. And that is what is called natural numbers. Okay. Then you came to primary school. Then, in grade 1 or 2, whatever, you learned there was a number in front of 1. Not so? And that number was? 0. Okay? You felt like you were lied at home all the time. No? And the 0 wasn't taught to you. Now you feel betrayed, not so? Yeah. And so now at school, they grade 3, whatever, grade 2, we now start 0, 1, 2, 3, 4, 5, and so on. So you thought you knew maths hundreds, no? So now you know about 0. And that is what we call counting numbers. Then you came to grade 6. Grade 6 years. Then the teacher told you about, don't get too excited because there are numbers before 0 as well. Which grade did you learn about negative numbers? Grade 6. 4. Okay. It's grade 6. I think it was grade 6 and 7. So grade 6. So grade 6 they spoke about these numbers before 0. Not so. Then you felt big, like you're talking about negative things here. Negative numbers. Negative temperature. Negative age. How can you have a negative age? What else do you get in negative numbers? Come, people. Money, yes. Accounts. Yes. When your bank balance is negative. Overdraft, yes. So you spoke about negative numbers. Not so? Yeah. So you got 0, 1, 2, 3, 4, 5, 6. On the other side of the number line, you got negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, all the way to negative infinity. You guys know what infinity is, no? This carries on forever in the one direction and negative on the other direction as well. And these numbers is what we call integers. Okay. Then you thought you knew it all until they knocked you upside down with fractions. Fractions. Fractions you did before negative numbers, not so? Fractions, yes. When the teacher, she bought everybody pies, no? You buy big pies and then she cuts it up into halves. And then you cut the pie into quarter and you cut the pie into with a cake. What do you guys use, cakes or pies? Pizza. I was like pizza. Right. Yeah, some use pie, some use pizza, but this was the opportunity to eat. Not so? So that's why I remembered fractions. Fractions to be so nice, and today I have what I have, no? You know. But importantly, we spoke about fractions. Okay. Then they also spoke about decimal numbers. They showed you how a fraction, which is 0, which is a half, can be written as 0.5. So after fractions, they spoke about decimal numbers. And to you, those decimal numbers always stop. Like if you got a quarter, what's a quarter in decimal? 0.25. What is an eighth in decimal? 0.125 and so on. Okay. And you got 0, if you got 1/5 as a decimal, that's 0.2 and so on and so on and so on. Not so. 3/10 can be written as 0.3 and so on and so on. No? So that is what we call a terminating decimal. The decimal stops. 0.25, 0.125, 0.0625. The number stops. Not so, the decimal stops. So if the decimal stops, we call that. You guys, what's a terminator? It's a very old movie now. Okay, what does it mean to terminate? To terminate. The terminator killed everybody. Okay. So to terminate something, it means to stop it. So that's a terminating decimal. The decimal stops. Not so. Then you get then you get fractions. We spoke about that now. So fractions, terminating decimals. Then you get a number that recurs. Well, who can tell me what does it mean to recur? Keep on moving, doing the same thing. Not so. So to recur means to say to do the same thing over and over. So if you're looking at a terminating decimal number, like if you got 1,333, and that carries on forever, this can be written as 1,3 with a dot on top. Means to say it's 1,3 recurring. So these are recurring numbers. So rational numbers, this is now a rational. The rational category, okay, is mentioned with a Q. It's marked with a Q. This is the symbol for rational numbers. So it's integers over integer, which is a fraction. It's a terminating decimal. Those are the numbers we spoke about. And recurring numbers. All three of these together forms the rational numbers. Now every terminating decimal, like I said, 0.5 can be written as half. 0.125 can be written as 1/8. 0.3 can be written as 3/10. What do you notice? Every terminating decimal can be written as a fraction. Can you see that? Every terminating decimal can be written as a fraction. That is why we say that the terminating decimal number is always also a rational number. Okay, you understand? If you look at 0.3 recurring, 0.3 recurring, you look at that on the calculator. Now I know that is 1/3. I know you're not supposed to be using a calculator. But you see that? That is 0.33333. So that's 0.3 recurring. Can you see that? What if it was 2/3, which is 6 recurring, 0.6 recurring. Can you see that? Because this calculator doesn't have an infinity, what's his name here? It doesn't carry on forever. It terminates. So the number is rounded off here. Can you see that? That is why the last number is a 7 on the calculator. Do you guys understand? So what do you notice? That every recurring number can also be written as what? As a fraction. Can you see that? That is why we say here, every terminating decimal and every recurring number and every fraction with an integer over an integer is known as a rational number. You can make a note in. That is why the author of this book didn't put this in here. Why? Because the recurring number can be written as fraction. Because the terminating decimal can be written. Does it make sense? Okay, but we're going to leave it there so that it can remind us. R stand for real numbers. Okay. And real numbers are made up of rational numbers plus irrational numbers. So we know what the rational numbers are, not so? So now we're going to look at what irrational numbers are. Okay. Yes. So on page 1, they gave you a list of natural numbers, all even numbers, all odd numbers, all prime numbers, composites, squares, cubes, all of these numbers and more forms natural numbers. They say the subdivision of natural numbers. Rational numbers are all integers. Now we take you one back here. Integers, you see here? They say all integers are rational numbers. But if you look at number 2, is number 2 a fraction? No. So why do they say that 2 is a rational number? It can be written as 2 over 1, which is a fraction. Not so. If we look at 0, can 0 be written as a fraction? Yes. Not no. Yes. How can it be written as? It will be written as 0 over 1. Negative 5? Negative 5 over 1. Negative 1050. Negative 1050 over 1. So every rational number, every integer is a rational number. Let's look at at counting numbers, also known as whole numbers. Is 3 a rational number? Yes, it can be written as 3 over 1. 15 over 1. Natural numbers. 100 over 1. So every integer, every natural number, every whole number is also rational numbers. Not so? But every natural number is also a counting number. Not so? But every counting number is not a natural number. Why? Because of the 0 thing. But at this point you should all agree that all natural numbers are integers. Not so? But are all integers natural numbers? No. Are all integers counting numbers? No. Is all counting numbers integers? Yes. You make sense, people? So the whole set of natural numbers belong to counting numbers, but not the whole set of counting numbers belong to natural numbers. Okay. Then, let's carry on. Here they say rational numbers, we're still on page 1. All integers, all fractions, all finite decimal numbers, fractions, all recurring decimal fractions. Okay, we still spoke about the finite, or what did we say for finite? Terminating decimal. There's another word, it's actually a better word than what I used. They're using finite, which is also terminating decimal numbers, which means to say it stops. Then we are given examples of rational numbers. As we said there, it can all be written over 1. And I gave you those examples there already, how the recurring number can be written again. Okay, common fractions. Okay, you guys can read through page 2. It deals with common fractions. Okay, there's recurring decimal fractions can be written as common fractions that we're going to do in later on's lesson. Okay, but for now, I want you guys to list the following. Okay, another bell is going to ring now. We are going to draw a table, okay? Now to eat on. for the following numbers. Okay. So this is what I wanted the table to look at. It's on page 6. So you're going to draw a table looking like this here. And so on. No? So the first category you're going to put in the in, and what does the in stand for? Natural numbers. You're going to put in O, which means counting numbers. Then you're going to put the Z, which is integers. Then you're going to put the Q, which is rational. Then you're going to put the Q dash. Now that we'll speak about in the next lesson, another balance learning soon. That's going to be irrational numbers. Okay? And then below that we're going to write here 1 over 7, negative 3, square root of 9 over 16, negative the cube root of 8, and so on and so on. Can you see that, people? We're going to have a long table. Okay? You guys know what to do. Alright. So draw that up so long. In the next lesson, I'll highlight you what irrational numbers are, and we will complete this table. Okay?